So thanks for joining us. We are here today to talk about after-treatment problems, specifically new technology and some surprising solutions that the world's leading OEMs are using to address these really challenging after-treatment problems. So we have on with us today some large heavy-duty fleets, some OEMs.
Pretty good mixture.
Yeah, really nice mix of people from several countries, as a matter of fact. So that's pretty cool. So good morning if you're on the West Coast, good evening or good afternoon if you're on the East Coast. And the big question is, Mark, everywhere we go, every industry gathering, what we hear is a lot of talk about after-treatment problems and excessive regeneration and trucks being sidelined, downed trucks, how costly this is, how many hours organizations are spending managing after-treatment. And up until now, it's just been assumed that this is just part of doing business.
Right.
And this is all quite recent, just in the last short while. So why are these after-treatment problems such a big deal now, and why is high-pressure leak detection such a big, important conversation?
Well, sorry. The after-treatment problem is a necessary thing, meaning the government gave it to us to clean the air. Just like 20 years ago, 25, 30 years ago now, it came to automotive. Trying to, better the environment. The problem is the equipment that they added to the trucks and heavy equipment, it works. It works. It cleans the air.
SCR and DPF system.
That system is a proven system. It's actually a pretty good system, and it's not going away. So now we get to deal with it. So a few years back, we never had these problems. Now we have these problems, but the real problem is the way we address the diagnostics and the maintenance of the engines to deal with after-treatment.
So heavy duty is now dealing with the challenges that automotive dealt with a few years ago with the onset of OBD2 and Euro 6 and these stricter emission standards.
Exactly.
And now HD is having to deal with the same thing because air quality standards are just going to get tighter as we go forward.
Well,
right?
The bottom line is our equipment deals with built-in issues in the vehicles that have to be given to part of a maintenance program. Whatever happens upstream in the system comes downstream, and the after-treatment system has to deal with it, has to clean the air. It's striving to clean the air. But if you have a bad product coming downstream, it works twice as hard or 3 times as hard.
So you're talking about something called upstream component faults.
Exactly.
So we recently published a white paper that was over 24 months and over 100 heavy-duty trucks of field tests.
Right.
And one of the most surprising results of that, and these were across many different fleet facilities, and consistently what we saw was that 89% of vehicles that had after-treatment problems, where they were having excessive regeneration or down trucks or losing MPG as a result, the root cause of these after-treatment problems was actually in upstream component faults. So tell us, what is an upstream component fault?
Well, it can be anything upstream of the after-treatment, meaning a cracked exhaust pipe, a loose clamp, a charge air cooler that's leaking, any type of air leak especially. And that's, of course, what we deal with is air leaks, simple air leaks. You'd be shocked about what a simple air leak upstream does to downstream components. So a fault can be many different things, but a lot of times it's a very simple issue, a simple air leak. Our equipment deals with something you can't see, which is air. Our tool visualizes an air leak, and that has to be addressed as mundane as the PM of your truck. your preventive maintenance program. Looking for air leaks can solve a huge amount of problems and save a huge amount of money when it comes to after treatment expense.
89% of the time, the root cause of these after treatment problems is upstream component faults.
Right.
And an upstream component fault, the best made vehicles in the world, right? Roll off tight and they go through grueling conditions. We're talking about ice and snow and construction and agriculture and all of these settings.
Dirt roads, potholes.
And so this can be flanges,
gaskets, O-rings.
sometimes bigger things, C's, turbos, etc.
Right.
But oftentimes not big things that you wouldn't necessarily go to. So what we're looking at here is not always large items, but really important places where if you're getting a place that it's throwing on, if you're getting additional air, right, where you're losing pressure, you're losing MPG, and then what's the result?
What happens is your engine management system on your engine compensates. If you have an air leak, it compensates with more fuel to get the air-fuel mixture correct. However, that wastes fuel economy, right? It costs you money with fuel, but also the after-treatment system has to deal with all that extra fuel that's passing through the engine. So it taxes your system. More AdBlue, more regeneration, it's on and on and on. It taxes that
more often, and more maintenance, more DPF filter maintenance.
Exactly.
Right?
More expense. More expense. A simple gasket can cost a truck thousands of dollars in expense, and it's not even realized.
So up until now, what was the best practice for finding these, difficult upstream components?
Well, which is shocking. It's soap and water. A spray bottle with soap and water, or a mundane test was, well, it's either the turbo that's bad, or it's either the charger or cooler. It has to be one or the other. Nothing in between.
Both expensive.
Both expensive. But if you're replacing parts and doing a test that doesn't test the whole entire system in 10 minutes or less, you're missing a lot.
So tell us, how exactly does the technology work? Because you just said a little bit about how to test the whole system in 10 minutes. So very simply,
well,
for those of us who are not engineers, tell us how it works.
We both like to talk with our hands. With the collaboration of several OE manufacturers, heavy duty, international trucks, for instance, they took our tool and with their help adapted with high flow, higher pressure than our evap style machines. And I don't know whether anybody's familiar with the term evap. It's fuel vapor recovery system on automotive, which has to do with gasoline. We manufacture forever low pressure machines. So those low pressure machines are fixed at 0.5 psi. Very low flow volume, air volume. Well, on a truck, you have a big system. Well, we had to make a machine that met the needs of a big system. But what you do, you simply put a expandable adapter in the intake, seal it off, seal off the exhaust, and test everywhere in between.
System.
Right. You have you're plugging the two largest escape for air, the intake, exhaust, right?
And then injecting invisible vapor, compressed air.
Yes.
So even if it's hidden within an engine, you can see where that small fault might be coming from.
And that's what the manufacturer is looking for. Something quick, something simple, a test that's not going to take hours, but a test that can test the whole complete system at one time.
And then once the repair is done,
you put your truck back together, you retest. It doesn't take but a few minutes to retest. You already have the adapters in. Retest it, make sure you plugged all those holes. And you're going to save fuel, you're going to save tows, you're going to save a lot of diagnostic headaches down the road. Because people are always getting their scan tools. Oh, that code, I remember that code. It must be the DPF, gotta change it. Oh, it must be the turbo. I'm not getting any power. Well, guess what? You could have a simple air leak. and it's
Creating
disguised
profit.
as a bad turbo,
Sure.
wasting thousands of dollars.
So you mentioned the adapters.
Yes.
Tell us a little bit more about the adapters.
Well, simply, I can actually blow one up. This patented technology, and again, developed with manufacturers. The way we designed these is you can adapt to any truck, bus, truck, off-road equipment, easily inflate with compressed air. Oops. Sorry. Not on. Sorry about that. Inflate very quickly. Make a perfect seal. So then you attach the smoke hose, and it's a pass-through device. So you seal and pass through all at the same time. Put one on the intake right after the air cleaner, one at the tip of the exhaust. You're sealing the system. Whatever's in between is a problem.
So even within a single manufacturer, a single OEM, there may be different engine types, different intake sizes. So this eliminates having to have different hard adapters, which then allows for that very, very quick 10 to 15 minute test.
Correct. You don't want to take anything apart. In most cases, you just pull the air cleaner and stick this in the intake, inflate it, stick one in the exhaust, inflate it, and you have a sealed system. That's how quick and easy it can be.
Don't want to take anything apart because you could be creating additional leaks.
Well, you could be not finding the leak that was there because you took everything apart.
And this is only available through Redline.
Through Redline. It's a patented device through Redline.
So I know you said that this was developed with some OEs. Let's talk about that for a second. Sure. There are a lot of OEs out there that are leading the charge on this. So often, it's the manufacturers who recognize that they're going to need to plan in advance for these systems and are leading the way with new technology. So this equipment, this technology, and the adapters have been mandated as essential tools in every location for international, Navistar trucks, Nissan, Land Rover, Volvo trucks, Mack trucks, and then approved and being used every day with PACCAR, Caterpillar, Kenworth, Peterbilt, Chevy, GMC, Perkins engines. So as you can see, a lot of the smartest people in the industry are adopting this and really finding it's a solution in PM and in repair that's solving this root cause of the after-treatment problems. So we have a question from British Columbia. What's the higher pressure that you mentioned, and why 20 psi? How do you determine that right pressure?
Okay, well, it wasn't us. It was actually the manufacturers that determined 20 psi. Our machine develops up to 20 psi. Now, a lot of tests are performed under that. However, they determined, not us, that 20 psi is the magic number to put in these systems, and that's the safe pressure, not to exceed. Meaning you don't have to go over, it's simulating boost to a point, is the way I like to say. It's simulating boost conditions with the engine safely off, but not to exceed.
So you're able to test the engine, simulate the boost of a running system with the engine safely off, and the engine manufacturers are saying 20 is the right amount of pressure, 20 psi.
And you could run into problems anything over that, and in your complete system.
So more pressure is not better. There's a right amount.
It was always, I worked in the shop for many years, and it was always more is better. But in this case, don't need it.
Got it. So how are some of the OEMs using this? I'm hearing that they are focused on, obviously, brand loyalty, improving customer satisfaction, so that when they do service vehicles that are done right the first time. With fleets, we talked a little bit earlier about improving MPG, which a small improvement for a big national fleet, many of which
Well, that's what we
have.
that's what we
this.
yeah, even a tenth of a mile per gallon is a huge cost savings.
Sure.
So if you have just for instance, a leak in the turbo side, the intake side, you're losing boost, you're losing power. The driver is just conditioned to push the foot down on the pedal more. That only costs more money. And normally, that's not a concern that unless it's a huge leak and there's no power, the driver normally doesn't complain of lack of power. I mean, that is a complaint, but it's usually a gaping hole, right? It's not those little holes.
Sure.
And that's the ones that are costing, you know, sometimes millions of dollars in big fleets with fuel. You know, a tenth of a mile a gallon makes a difference.
It's substantial across thousands of trucks running across. So I do have another question from someone who's joining us in Texas. Thank you for joining us. And it's asking about the applications for buses.
Yes.
So there are big bus companies that are using this, and also agricultural applications, farm equipment, construction equipment, mining, military vehicles.
Yeah,
right?
It's across the board. It's
marine.
Yes.
Transport, like smaller sprinter kind of style vehicles.
Also power generation systems.
There you go.
You know, there's a lot of that, right? You're working with off-road equipment. You're also working for what they call gen sets, generation electrical. Those need tested all the time.
And my understanding is that because the patent adapters, these are very heavyweight, very professional grade, right? Because of this technology, the applications are much wider, right? So you don't have to have distinctive adapters.
Yeah, the whole key is universal fit, right? Because we don't know what the manufacturer is going to put out 3 years from now. And it'd be a shame for you to invest in this equipment and then not be able to adapt to your current product line.
Absolutely.
Right? And it's all about taking care of the customer. You take care of the customer right the first time, and it's unfortunate they have a problem to begin with, but if you take care of them the first time they come in and handle their problem, diagnose their issue, that is customer loyalty building up. And then they're going to buy your equipment the next time, because they're not going to say, hey, that truck was down for 2 weeks and I lost my shirt. I'm never buying that kind of equipment again. And there are original equipment manufacturers that we didn't mention that have bought our product to build their quality.
Absolutely.
You know,
Absolutely.
for their R&D departments. I could name several.
What we do know is that these after-treatment systems are here to stay. Air quality standards are continuing to become more stringent. And so technicians need tools and equipment to be able to work on these systems. And since we know that much of the root cause of after-treatment problems is in the upstream component faults, this technology has really been key. When we go to industry gatherings, when we go to any of the big trade shows, the TNC, this is really the conversation right now. And the ROI is really demonstratable. If you haven't seen it, I would suggest that you download the white paper, because there's a lot of great data in that about the applications and about the ROI.
You know, even a DPF service, right? You know, particulate filter. You know, when you have to take the exhaust apart to service that filter, right? Well, how do you know you installed it correctly and sealed with those clamps? Because there's corrosion, there's issues. It was just a few days ago, I was at a major OE, and they had a truck there that I was training their field service engineers with, and it had leaks at the DPF. And I guarantee you that was just, they took it off probably to service the filter, which is a biannual thing minimum nowadays, depending on the mileage, of course. But when you put those clamps back on, you may be creating a bigger problem than you had before you service the DPF. So charge air cooler leaks, clamping issues, DPF, EGR cooler testing. How would you like to be able to test an EGR cooler on the vehicle without taking it apart? You can do that with the smoke machine. Any kind of exhaust leaks, it's a common problem. That truck gets rattled apart on the open road. You know, it doesn't have to be an off-road truck. They are used just by the condition of our roads, right? You have to check for leaks at the preventive maintenance. You know what? Another thing is checking to see if you even have a cracked or faulty DPF using the smoke machine. A simple test without taking it apart. 5-minute test, you can determine whether you have a cracked or dislodged particulate filter with our smoke machine.
That's pretty impressive, I have to say.
Yeah. It's a quick, simple tool, and within 10 minutes, you can have a definitive test of whatever leak you want to find.
Well, there are thousands and thousands of these working in the field, have been for the last couple of years, 24, 36 months.
Right.
I think the number is 112 countries are using this technology.
And counting.
And counting every day. This equipment, all of our equipment is made here in the USA.
Yes.
So, and we're all right here. So I would urge you to look at the white paper. I think that there will be helpful information there. And please reach out to us. You can find us at redlinedetection.com. You can send us a message. You can give us a call. We are here to help you to answer any questions about applications or go a little bit deeper into the technology. And,
I can certainly, if they call, I can talk your ear off. I've lived it, so I know what I'm talking about.
So we're happy to help you. Please reach out to us. Let us know how we can be of assistance as you work with your team to deal with these challenges. And in the meanwhile, thank you for joining us. It was great to see you all here.
Thank you.